Good morning to all. Myself Arun Kumar. I am working as an assistant professor in the Department of Information Technology, K.S.Rangasamy College of Technology, Tiruchengodu. Today we are going to discuss about Translator. A translator is a program that convert high-level language program into low-level language program or binary level language program or machine level language program. So the high level language program is that if you are going to design any of the user can be defined by the program, that program is a high level language program. The machine cannot understanding the high level language program. Using the translator concept, it can be converted into high level language program into machine level language program or low level language program. The low level language program is a zeros and then ones, that is a binary representation. So then only the system can be understood by our program. There are three different types of translator. The first one is the compiler, the second one is the interpreter, the third one is the assembler. Compiler is a one type of translator which is used to convert program in high level language to low level language. So I am already discussed that the high level language program is a user defined program. The machine cannot understanding the high level language program. Using the translator, different types of translator, based on our user convenience we are going to choose particular translator. Types of translator, it can be converted into low level languages or binary level languages. So based on that only the system can be understood by our program. It translate the entire program, also report the error in source program encountered during the translation process. The main advantages of the compiler is if having the 100 lines of program, the same time it will read the whole program. It will scan the 100 lines of program. After that only it will show the total number of errors are arised in that program. Finally it will display the number of errors are in that program. This is the example diagram. The source program is a user input, that is a high level language program. The compiler is the one type of translator. The user program, high level language program, using the compiler translator it can be converted into target program. If having any error in that particular programming, it will display the error message. That is the types of compiler. The next one is the interpreter. The compiler and then interpreter, the major difference is the compiler it will read the whole program. After that it will show the number of error in that program. But interpreter it will read the line by line manner. If there is any error in that particular line, after clearing that error only it will move to the next line. So whenever we are going to rectify that error, then only it will goes to the next line of the program. Otherwise it will not move to the next line. The interpreter translate line by line and report the error once it encountered during the translation process. It directly execute the operation specified in the source program when the input is given by the user. This is the example diagram for interpreter. The user source program or high level language program, otherwise we can represent it as the input. So if we are giving the high level language program using the interpreter translator, it will be converted into output. The output may be a high level low level language program or machine level language program or binary level language program. So the binary level language program is the zeros and ones, then only the system can understand this particular output. The next one of the type of the translator is the assembler. The assembler is used to translate a program written in assembly level languages. So assembly level languages, that is a mnemonics code. So that is the opcode is move, add, sub. These are all the assembly level languages, that is a opcode. Using that compiler it will be converted. If some of the C compiler directly convert the high level language program into low level language program or machine level language program, then some of the C compiler convert the high level language program into assembly level language program. The assembly level language program system cannot understand directly. So using the assembler translator, again it will be converted into low level languages, then binary level languages. So this is the example diagram: source code, assembler, then executable, machine code. So here the source code is here it's not a high level language, that is the assembly level language program. Using the assembler translator, again it will be converted into low level languages or binary level languages. The next one is the grammar. Generally, a grammar is a set of rules. So, based on that rules only, we are going to generate a grammar. It is a finite set of formal rules for generating syntactically correct sentence of meaning correct. So, here we are using the 4 different components, that is a VTPS. V is a variable, T is a terminal, P is a production, and then S is a starting symbol of the grammar. So based on that component only, we are going to generate a grammar for any type of real world problem. So here a variable is the either uppercase letters, capital A to Z, alpha, beta, comma. So these are all the variables. T is a terminal, means that is a lowercase letter, small a to Z, 0 to 9, then some special symbols, plus addition, subtraction, multiplication, division. So these are all the terminal representation. The next one, P is the production. The production is the formula for representing a grammar production is any one of the non-terminal tends to in her right hand side either terminal or non-terminal or combination of terminal and the non-terminal. So these are all the format for representing the production. The next one is the S. S is the starting symbol of the grammar. The starting symbol of the grammar is always the uppercase letters. So this is the one of the example problem for context free grammar. Write a context free grammar for palindrome string. What type of string can be generated using the palindrome? Amma and then madam. So here we are using the 2 different input are using S, A, M and then D. So these are all the input symbol. S is the starting symbol of the grammar, A, M and then D. The palindrome string can be generated with the middle string and then without middle string. So based on our user convenience, the string can be generated by our own. So the production starting symbol. So S is the starting symbol of the grammar. So the palindrome string means, for example, Amma. Amma is the one of the palindrome string. If we are going to reverse that string, it will be produce the same meaning. So we are going to generate a grammar for that particular problem. So any one of the non-terminal. So here the non-terminal is the S. S tends to A, S, A. The same non-terminal will be repeated. So S tends to A, S, A or M, capital S, M or D. Because of that, here D is used for the middle of the string. The palindrome string can be generated by with the middle or without middle. If you need, we are going to use that. So that's why here we are mentioning the D. So this type of grammar can be generated by the madam, also Amma. So any type of using that A, M, D, using that these are all the input. Using that input, we are going to generating the many number of palindrome string using that grammar. Next problem is construct a context free grammar for language L equal to W is any one of the word. The C is a constant, W power R. So the W can be reversed after constant value. The W will be a reverse a string WC W power R, where W that belongs to the input symbol is A comma B the whole star. So here the starting symbol of the grammar is S. S tends to A, capital S, A. Because of that, the first letter after constant value, it can be the same letter will be displayed. So here S tends to A, S, A. Here we are using 2 different input symbol A comma B. So S tends to A, capital S, A or S tends to B, capital S, B. Otherwise the constant value we can represent it as C. So that's why S tends to the middle of the term is C. So that's why here we are mentioning that. Then another representation of construct a context free grammar for the language L equal to n number of A followed by 2n number of B's, where n greater than or equal to 1. So if you want to print single time of A, double time B value should be immediately printed. So that's why we are going to generate a grammar. So based on that grammar, VTPS, that is a component. So S tends to A, capital S, B and then B. If 1B, 1A, 2B, that is a n number of A followed by 2n number of B's. If you want to print single A, immediately it want to print the double B's. So if it is in a 4B means 4 A's means 8B will be displayed. So based on that we are going to generating the grammar.